introduce this formula this way, is what's the sine of pi over 6? Here's the circle. Turn to your neighbor. Tell him what the sine of pi over 6 is. Go. Hopefully you know it. What do you think, Ella? Sine of pi over 6? Nice. Perfect. Perfect. You can kind of see, too. Here's the square root of 3 over 2. That's the long side. This is the short side. That's the y is going up. 1/2. Okay? Now, if we said the sine of theta equals 1/2, you know that theta is going to be pi over 6, right? And what if I asked for, well, that's kind of a, I don't like that. I want to try something different. That's good, though. What is the sine of pi over 2? What's that equal to? Here's my unit circle. Here's pi over 2. What's the sine? Very good. Okay. What's the sine of pi over 2 plus pi over 2? Go. Turn to your neighbors. Tell them what to think. I love this question. Somebody's going to get it right, and somebody's going to get it wrong. How many say 2? How many say 0? Okay, I get a lot of zeros out there. If the sine of pi over 2 is 1, why wouldn't it just be 1 plus 1? Because it doesn't work that way, right? Because this is pi over 2, right? And if I go another pi over 2, what's this y value going to be? It's 0, negative 1, 0. So this is actually 0. Were you kind of fooled a little with this sine of pi over 2? Didn't you just want to say that this was equal to sine of pi over 2 plus sine of pi over 2? Didn't you just want to do that? You really did, didn't you? But this is an old idea that's wrong. You know this from the past, because whenever we have a function, adding in a function isn't what it seems. For example, what's the square root of 4? 2. What's the square root of 4 plus 4? Is it equal to 2 plus 2? Never has, never will be, right? How about the square root of x squared plus y squared? Is that x plus y? No, because they're missing that middle term. So you know this for a fact. This is my number one thing I want you to see before we go in. These two are not equal. Just like these are not equal. These are not equal. These are not equal. Clear on that? That's going to help. Now, can you go to this screen here? I'm going to blow your minds here with a bit of a crazy proof. And can you show me this slide when you find it? Good, good. How about in back? Great. Jacob, how are we doing? Can I see yours? Okay, get there, please. Thank you. So, what we're going to do is we're going to prove this weird formula. Before we do, just a quick little from the past. What's the distance formula? Square root of, if we use x and y, is it like x2 minus x1 squared plus what? y2 minus y1 squared. We remember that. It's been a while. What's cosine squared plus sine squared? Cosine squared plus sine squared is 1. Very good. And if cosine theta is the x part, what's sine theta? The y part. So we're going to just remember those for this proof. And we're going to prove something kind of crazy. I got this from a teacher who teaches in northern Minnesota, who got this from a guy in California. And I love this proof. It's not an easy one, but it's pretty awesome. We have our unit circle. Here is 0.10. Here is an arc length on the circle B and an arc length on the circle A. So you can maybe imagine pi over 3 and 2 pi over 3, but we'll just call it A and B. Now, instead of xy, we're going to call this the cosine of A, sine of A. What will this one here be? This is arc length B. Cosine of what? B, comma, sine of B, right? We got that. Now I'm going to do something weird. I'm going to say, okay, I want to know what this distance here is. Okay? I want to know what this distance, if I went all the way to A and I went all the way to B, I want this distance here. Now, it's kind of hard to imagine because this isn't going to slide very easily. But if I slid it down here, if it's like a chain, this chain, and I pulled this chain all the way down to here, can you kind of imagine that this is going to be length? See, that's a color I haven't used yet, purple. A length A minus B. Because let's say A was 10 and this was 7. What would the length here to here be? If this is 10 and this is 7. 3, right? Or if this was 12 and this was 8, it would be 4. It's just A minus B. So what is the coordinate of this spot? Cosine of length what? A minus B. That's the x. The y is the sine of A minus B. Annoying? Yes, but kind of makes sense. So one more time. These two go together. These two go together. And these two go together. One is the coordinate and one is the arc length. Doing okay so far? All right. Now I'm going to make a statement that I think you're going to agree with. I hope. Do you see the distance from A to B? See that distance? How does that compare with the distance from A minus B to here? How do those distances compare? So this is A and this is B. I grabbed this chain, I pulled it down here. Do you agree that this distance 1 is the same as this distance 2? No? Okay, so here's what I did. I took this length here, think of a chain, and I cut it off here. And then I took the chain and I drug it all the way down to here. Wouldn't those have to be the same? Yeah, they would. So below here, would you write D1 equal to D2? Now this is where the fun begins. We're going to use the distance formula to figure this out. I'm going to call this one x2, this one y2. I'm going to call this one x1, y1. Seems kind of weird, but this is the direction I'm going to go. Now I'm going to use your statement, the distance formula, that said that the square root of x2, which was cosine A, minus x1, which is cosine B, squared, plus sine A minus sine B, quantity squared, it's going to be equal to, now I'm going to do this one over here. I'm going to use black here. This is going to be x2, and this is x1. Here's y2, and this is y1. So this is going to also be a long square root And then we're going to go x2, which is the cosine of a minus b, minus 1, quantity squared. And then the other one is going to be this one up here, sine a minus b, minus 0 squared. Now, once we have this, would you do me a favor and square both sides? So all of a sudden, this and this disappear. Is that okay? Just do me that little favor. Just make life a lot easier. Done. All right. Now let's practice. What is cosine A minus cosine B times cosine A minus cosine B? Let's see what that is. FOIL it. You're going to get, I'm going to use purple here, and I'm going to write small because I think I have this theory that I can get this to fit. I hope. Cosine A times cosine A is cosine squared A. Then it's going to be minus cosine A cosine B. And then it's going to be minus another one, cosine A cosine B. Can I just shorten that into minus 2 cosine A cosine B? Are you okay with that? Is that good? And then the last one's just going to be plus what? Cosine squared B. Nice. Got it. Let's use another color for this one. And I'm going to do this without writing it out. Sine A times sine A is sine squared A. And then we're going to have minus sine A sine B, or minus 2 sine A sine B. And then I'm going to have positive sine B, or negative sine B times negative sine B. It's going to be positive sine squared B. That is equal to, now I'm going to use another color, blue. Cosine A minus B times cosine A minus B is cosine squared A minus B. And then it's going to be minus 1 times this, minus another 1 times this, be minus 2 cosine A minus B. Is this like your biggest math nightmare, this proof? This is the hardest proof we do all year, by the way. So if you handle this one, you're at the tippy top. If you can't grasp it right now, just do what you can. Just write everything down. All I'm doing is algebra, foiling. And then I also have a negative 1 times a negative 1, which is a positive 1. Okay. And then the last one, oh, you did me a favor there. Sine A minus B minus 0 is just going to be plus sine squared. Did I make it? So close. So close. If you can't see that, it's sine squared A minus B. That's what that is. All right. How we doing? How we doing? Doing okay? Now, that looks horrible, but we can do something about it. We can do this one and this one together. What is that? Oh, that's not true. Back up. This one and this one together, what do those add up to? Oh, what do these two add up to? 1, okay. What do these two add up to? Cosine squared A minus B, sine squared A minus B, same arc length. Cosine squared plus sine squared equals 1. Very good. So what that means is you're going to get 1 minus 2 cosine A cosine B. And then you're going to get another 1 minus 2 sine A sine B. And on this side, you're going to get 1 minus 2 cosine A minus B plus 1. Does that look a lot better than, Ella, tell me what I can cancel on here. It's got to be something. Something to lay waste so we don't have to deal with it anymore. Cam, can you help her out? Anything we can cancel? I know it looks terrible, this stuff. There you go. Take out a 1. What else can we take out? Another 1. Yep. So then all that I'm left with is negative 2 cosine A cosine B minus 2 sine A sine B equals negative 2 cosine A minus B. Give you a chance to write that down. Now what can I get rid of? What can I get rid of? Can I divide by anything? Both sides? Yep, negative 2. Okay, and I know this isn't your favorite thing in the world. I get that. But this is where math gets incredibly powerful. Cosine A cosine B plus sine A sine B. That's the formula for the distance formula, cosine A minus B. Or if I wanted to go the cosine of pi minus pi over 2. Well, I know on the unit circle, the cosine of pi is negative 1. Cosine of pi over 2 is 0. Is it negative 1 minus 0? Is it the cosine? Is it the cosine of pi minus the cosine of pi over 2? Is that true? Is it? Is it negative 1 minus 0? Is that true? Because the cosine of pi over 2 is going to be 0. So that's not equal to negative 1. So we can't use this formula to do that. We can't just first minus distributive property. Doesn't work. But we could do, we call this A and this B, and there's a minus in between. You can literally do the cosine of pi times the cosine of pi over 2 plus the sine of pi times the sine of pi over 2. And this will work out to give us 0, which is going to be negative 1 times 0 plus 0 times 1. And is that equal to 0? Oh, yeah. So this formula works. Distributive property, doesn't work. How are we doing? That's pretty crazy stuff. Okay, go down to, please. Would you go down to the homework? And you're probably at this point saying there is no way I can do anything with that. Wrong, untrue. Go to day 1. What we're going to do is we're going to use this formula and a couple other ones to figure this out. So I'm going to give you the formula cosine A minus B is the cosine of A times the cosine of B plus the sine of A times the sine of B. That's the cosine of A minus B. Wouldn't it be great if there's a cute way to remember this? This is a horrible formula, don't you think? Well, you're going to have a great way to do it. A student from South America told me that she had a way down in Peru that they remembered it. For cosine A minus B, they just remember, how many speak Spanish? Coco CC is what she remembered. And if it's cosine A plus B, the only thing that's different, it's still cosine A, cosine B, and then this is minus sine A, sine B. And it's coco minus CC. So whatever the sign is, you do the opposite in between. But think of this as coco CC. For the sine of A minus B, this is C co plus cosine. Cosine not showing up very well here. Cosine A sine of B. And then if you have the opposite sign, A plus B in here, it's going to be sine of A times cosine of B minus cosine of A times the sine of B. Everything's the same except the in-between sign is the opposite. Well, I should say for seco cosi it's minus, and these should be also, the yellow one should be minus, and this one should be plus. So using those formulas, you can do all of this, no problem. For example, number 1, you're just going to call this A and this B. This one's A and this one's B. So you're going to have the seco minus cosi. So sine of 3 pi times the cosine of 2 theta. Then it will be minus the cosine of 3 pi times the sine of 2 theta. So you just use those formulas and then crank them out. So with this one, you're going to have sine of 3 pi, 1 pi, 2 pi, 3 pi. What's the sine of that? How far up do we go? 0. And then the cosine of 3 pi is going to be negative 1. So 0 times anything is 0. Negative is a positive. Sine of 2 theta. That's what that's going to be equal to. We'll deal with these minus signs a little bit later. Let's go down to number 22. If you can handle this, you're going to be in great shape with these. If alpha is in quadrant 4, cosine alpha, sine alpha is in quadrant, looks like quadrant 2. Find each of these. I have 3 minutes left. Here's what I'm going to do. For tomorrow, here's your assignment. Do 22, 23, and 24. You're going to use those formulas that I gave you, and then I'm going to set you up with a triangle, and then you're going to figure this out. I'm going to make two angles means 2 circles. 2 angles means 2 circles. The first one, we're in quadrant 4. So we're going to have this triangle, alpha. You okay with that? Cosine is square root of 5 over 5. You okay with that? And you could do 25 minus 5, square root of 20. No problem. This will be negative in quadrant 4. In quadrant 2, you've got this. This is going to be beta. Okay? 2 angles, 2 triangles. So this triangle is going to be in quadrant 2. Okay? The sine is opposite over hypotenuse. And this is going to be square root of 90, I think. Okay? From this, now you take these formulas, cosine alpha plus beta. Was that the coco CC one? Right? So you're going to take that formula, and you're going to go cosine of alpha times cosine of beta minus sine of alpha times sine of beta. You use the alpha triangle, cosine and sine. Use the beta triangle for cosine beta and sine beta, and just plunk them in. Put them into the formulas. Do the same thing for cosine alpha minus beta. Same thing. But put a plus sign in between. And I'm just going to do this first part because we've got a second here. Cosine of alpha, square root of 5 over 5. By the way, don't put it in for alpha. This whole thing is this whole thing. Okay? Cosine of beta. What's that? Tell me what the cosine of beta is. Anybody? Square root of 90 negative over 10. Good. Sine of alpha. Now we're going to go back to the alpha again. Sine is square root of 20 over 5. What's the sine of beta going to be? 10 over 10. So simplifying this, which is kind of horrible, it's going to be negative square root of 450 over 50 minus square root of 200 over 50. And you can just leave it like that. Good enough. There's your answer. Number one mistake students make is they put these in for the angle, but it's the whole thing is replaced with that. You're going to do this for here, and then do it for these other formulas through 24. Just do those. That's great. 24, 23, and 22. And one last time, cosine A minus B. What's the magical way to remember it? CC. Cosine of the first, cosine of the second. If this is minus, this will be plus. Sine A, sine, and B. And then the other one is cosine A plus B, which we'll prove tomorrow. Is magical way to remember it? Still CC. Cosine of A, cosine B, minus sine A, sine B,